Now the next problem is 6-point charges are kept at the vertices of a regular hexagon of side L and center O as shown in the figure. Okay, so we have plus 2q, plus q, minus 2q, minus q and plus q. Now it is given that 1 upon 4 pi epsilon naught q by L square is capital K. This is given to us. Which of the following statement is are correct? Okay, the side of the regular hexagon is L. Now we know from geometry that if the side of the hexagon is L, the total angle is 360. So each side will be making an angle of 60 degree. So this will also be 60-60. So it's equilateral triangle. So the length is L of each side as well as the distance between any of the vertices with the center. Okay, so this is one thing. Now first of all we find out the electric field due to the positive set of charges, that is at A, B and F. Now plus 2q charge will be having its force in this direction, or electric field in this direction. Okay, now this magnitude will be equal to 1 upon 4 pi epsilon naught 2q upon L square, because this distance is L. So this can be written as 2k. So the electric field is 2k because of A towards OD. Similarly, electric field due to B will be equal to 1 upon 4 pi epsilon naught q upon L square, which is equal to k. So this electric field is k. Similarly, electric field due to charge plus q at F is also k. Only thing is that their directions are different. Okay, now let us now find out electric field due to negative charges, that is at E, D and C. Now this length is L, OE is L and the charge is minus q, so the direction will be towards OE. So this electric field is k, this will be 2k and this will be k. Okay, now if we superimpose the total electric field because of positive and negative, then this k and k due to E will add up. So total electric field is 2k here, 2k here and 4k here. Okay, now is that clear? And this 2k and this 2k, which are equal in magnitude, they have an angle of 120 degree between them. And we know from vectors that if two equal vectors are inclined at an angle of 120 degree, then their resultant is also having same magnitude and passing through the angle bisector, and the angle bisector is towards OD. So towards OD now we total have 4k plus 2k, that is 6k. So the net electric field at point O will be 6k towards OD. Okay, now let us look at the options. Option A is the electric field at O is 6k along OD. This is correct. The potential at O is 0. Now that we have to study. Now we can assume that actually this is a regular hexagon, but if you only take these set of charges, that is at F and E, so it becomes a dipole. Okay, so considering the sixth set of charges, we have three set of dipoles, one at FE, another at BC and another at AD. Okay, now if we assume that there is no other electrical charge present in the vicinity of this set of charges, then there is no potential due to the environment. Whatever potential is there, it is only because of these set of charges. Now the line PR, if we extend it, this becomes equatorial line for all three set of dipoles. For this also it's a equatorial line, for this also it's equatorial line, and for BC also it's a equatorial line. And we know that the potential at any of the point on the equatorial line is always 0. Okay, so if we consider the sum of potential of all the three dipole at any point, let's say this point is W, right? So the potential due to this will be 0, potential due to this will be 0, and potential due to this dipole will be 0, and potential at point O will also be 0. But here we have to assume that no other electrical phenomena is present. So the potential at O is 0, and the potential at all points on the line PR is same. That's correct, because that's a equatorial line. Potential at all points on the line ST is same. This is incorrect.